Completing the square, completing the square, completing the square. You know what? No phrase in high school math has caused more heartache than complete the square, I think. And I know why. I need to tell you why, is that it has to do with practice. This is just one of those skills that has to be practiced. The good news is you won't believe me after day one. Yes? When I show you the basics of it, you'll think, oh, what's the big deal? It's day two of it that it gets interesting, okay? So that's sort of good news in our situation. You'll see day one, get the feel of it, and then after day two, you can judge whether this is a very difficult thing or not. So our learning goal, I will complete the square, whatever that means. Again, another learning goal that would be better as the last slide. Like, okay, what did you just learn? We learned something called completing the square. Doesn't sound too dangerous, does it? Complete a square. Yeah, that's good. On the standard form of the quadratic equation to write the equation in vertex form. This sounds like stuff we've been doing. Standard form, vertex form. It all sounds pretty friendly. Recall, and this is good for your review for your test for tomorrow, is that this goes through the whole procedure of how we find the vertex. Here's what we do to find the vertex. If it's y equals x squared plus 14x plus 40, we first factor it if we can. Yes? And this one factors with a x plus 4 and an x plus 10, because 4 times 10 is 40, and 4 plus 10 is 14. Our next move is to set y equal to 0, and that allows us to find the zeros. Hopefully you've done this enough times where you're like, yep, pretty good. Get two x values, the two zeros, which are -4 and -10. Quick sketch so you can see what's going on here. We found out that it has an x intercept at -4 and also at -10. That tells us the axis of symmetry and the vertex are halfway between those. And that's why we add them together and divide by 2. I like the little v here. This particular note doesn't have the little v there, but I like the x with a little v there to remind yourself, now I found the x value of the vertex, and you can sub that in to find the y value of the vertex. Maybe you're so good at that you don't even need this many steps, but that's okay. Here's the full steps again. Then you just state the vertex. That's the therefore statement. Therefore, the vertex is -7, -9. That's a lot of work. I won't lie. While we were doing it, I acted like, hey, no big deal. Yeah? We'll factor, set the zeros, add them together, divide by 2, and sub them in, and acted like no big deal. That's ridiculous. That's a ridiculous number of steps. Say, please, Mr. Todd, don't tell me you have something that's way better. I have something that's way faster. I will not say it's way better, because it's a little hard to follow exactly what I'm doing, okay? And that happens in algebra all the time. You get a new procedure which is faster, but loses some of the understanding. This is nice. It shows exactly what's happening with the vertex. That won't be as easy to follow with completing the square, but it will get the answer much faster, okay? That's my intro. A little investigation to see what I'm going to try to accomplish here. It says factor the following trinomials. Seems pretty straightforward. Factor x squared plus 6x plus 9. And I'm going to give away something so you know what you're looking for here. I have chosen these 3 particular trinomials because they're all very special trinomials. They may not look special when you first see them, but they are. They're extremely special. This is a simple trinomial factoring. I don't say it's simple. It's simple compared to the ones where you got to do decomp. The question is, what 2 numbers multiply to 9 but add to 6? 3 and 3 both times. We've already found out what this investigation is all about. If it factors as the 2 numbers are the same number, we could write y equals x plus 3 times x plus 3, and that would not be wrong. Except it's better like this, because that's in vertex form. I don't need to go through all the steps with this one to find out what the vertex is. I can see it's just a parabola that's been moved left 3, hasn't been moved up or down, and I can get the vertex right off of there. This should catch your attention. Maybe there's a shortcut. Maybe. You're like, well, maybe there's a shortcut for ones that you've rigged up to be nice. I know, but I'm going to use this as a lever against this algebra. We'll do 2 more just to really reiterate the point. What two numbers multiply to positive 36 but add to negative 12? Negative 6 both times. And so that's what makes these particular trinomials very special, because that could be written as x minus 6 squared, which is vertex form. It's a parabola that's been moved right 6. You should be sort of excited. You're like, okay. When this happens, we don't have to go through all those steps. We can just factor it. You should be sort of concerned, though. You're like, you've rigged these up. You chose very special ones to make that happen. I know I did. But I'm going to use it. Watch. One of the best math moves in grade 10 coming up soon. We do it one more time just to make sure we beat this to death, to make sure it's clear what's happening. And there's something else we got to pick off about this. You're bored, hopefully. What two numbers multiply to 25 and add to negative 10? Negative 5, negative 5. And it's not wrong to write it like that. But this is way better because that is vertex form. So this one we got lucky. The trinomial in question was a perfect square. It was something squared. Yes, it's still called perfect square. It was something squared. Here's the very tough part. Because it's 2 steps. I'll give you a clue. It's 2 steps. How do we get from 6 to 9? That is, how did I figure out that I should, to make these questions up, that I should use a 9 there? It happens here. I decided to put negative 12 there, and so I decided a 36 was needed to make this all work. And there was a negative 10 here, and I decided it was a 25 that was needed. When I was making these questions up, so try to read my mind and say, how did he decide? In fact, if you're onto it, I'll make up a new one here. Let's say I wanted to make up part D for you to look at. And I decided on what y equals x squared plus 8x. And I'm thinking to myself, what number should I use to make this work out again? Chris has it, but just let it process for a minute and really look at it. Chris is going to answer. He's got that confident look in his eye. I think he's got it. Because it's hard, but it's not. It's just 2 steps, that's all. You agree? It's sort of 2 steps. Do you think? He sort of agrees. First of all, what is the number?
I'm questioning it.
He's questioning it. He's lost his confidence. Because it might not be 2 steps. I take that back. Depending on how you look at this, maybe there's a 1-step way to go at it. Peter, what do you like?
I like 16.
He likes 16. Let's check if he's right and then figure out, and then we're going to ask him how he got it. What 2 numbers multiply to 16 and add to 8? 4 and 4. He's right. It's 16. But how did you get it?
Well, I knew that 4 and 4 add to 8.
Yeah.
And the C has to be what adds to 8 that multiplies the C. So 4 times 4 is 16.
All right. I'm going to do the long version of what he just said. He said if this is 8, we're talking about it has to be plus 4 and plus 4. That are the 2 numbers. I already know the 2 numbers. They're plus 4 and plus 4. It's half of this thing. Half of b squared. Okay. That's our quick way of doing it. You take b, you divide it by 2, and then you square it. It's difficult because it's 2 steps, but each individual step isn't a big deal. That's the magic number each time I did it. He said it in 2 steps. He said divide by 2, and then he said, oh, I know this number then is 4 times 4. Chris has just jumped ahead and said, oh, that's 4 squared. Yes? All right. We're on top of this already. We're on top of the basic structure of what it's going to take to complete the square. That C, to say in technical terms, that C has to be half of the b squared. You're still skeptical. You should be. Because you're like, well, what if it's not the right C? Oh, that's where I come in. That's why you paid me to come in today, is to make this work. Yeah? When it doesn't seem to want to work. That's my job. Okay. Notice all the simple trinomials were just factored our perfect square trinomials. They all had a value of 1. Okay, that's day 1. Yes? Day 1 of complete the square. We'll just do ones with a value 1. And hopefully, if I've done my job and you've paid attention, when I finish here, you'll be like, oh, that's not so bad. It's when the a value isn't 1 that things, just like last time, right? With factoring. With a value 1, everybody's like, oh, multiply to this, add to this. Not a big deal. But as soon as that a value is not 1, there's going to be a wrinkle in all this. Okay? Consider the following trinomial below. So what is it? What's the magic number? 36. I hope that's pretty straightforward. You're like, okay, I know what I'm looking for now. I need this b divided by 2 squared. And here's another way of writing b divided by 2 squared. I like my way better with the b over 2, all in brackets squared. But maybe you like this better, b divided by 2 squared. So b divided by 2, you think about it and you go, okay, the b is 12. Divide that by 2 is 6, and squared is 36. We need a 36 there. And again, you're still skeptical because you're like, well, what if it isn't 36 there? Wait till you see. It's the greatest thing. So simple, yet it's shocking what I'm going to do here. We would need to add the equation so that the trinomial could be factored as x plus something squared. Remember, we need the trinomial to be a perfect square trinomial. We're using a value 1 on day 1 of this. And the c value is half the b value squared. Let me get out my fancy highlighter for that. Highlight, and I'll go with orange. Some people complain that when I do red, they can't really read what's in it. So orange is my like, whoa, that's the important line. Like if somebody missed all this lesson up till now, and you could only tell them one sentence, say we need the c value to be half the b squared. That's the essential learning so far. Do you have questions? Still looming. How are you going to make this work? Oh, well, yeah, good. I hope I'm going to earn my money in just a second. What happened? There. Try this one. What would we need to add the equation so that it could be factored into x plus something squared? Okay, fill in the blanks. X squared minus x. One more time. What's half of negative 8 squared? 16. Some people go over here and they do this off to the side. They go b over 2 squared. They go, okay, negative 8 over 2 squared is negative 4 squared. And they show all this work over here. I'm all for it, depending on how big the number is. If the numbers are small, you might not need this work. But if the numbers are big, or if they're fractions, you may want to go over here and do a little thinking. So this becomes, okay, so what does it become in the brackets then? What two numbers multiply to 16 but add to negative 8? Negative 4, okay. Okay, so technically we can't just add a number because it changes the original equation. You're like, I can't just put that number in there anytime I want. Or can I? Here's my question for the day. What number can I add to an equation and its value doesn't change? There's only one number. You're totally allowed to add to an equation and not change it. 0. 0 is the only number you're allowed to add. That's what I'm up to today, 0. I'm going to add 0. I'm going to add 0. That's the only number I'm allowed to add. You're going to think I'm lying now. Get ready. This one says x squared plus 6x plus 21. What's the magic number? Go over here. Magic number. b over 2 squared, 6 over 2 squared, 3 squared. The magic number is 9. Whoops. 9. That's what I want. I really want a 9. That's not a 9. Do you agree that 21 is not 9? Okay, now you're going to watch me. You're going to think I'm lying. I'm going to do two different colors. Get ready for the dishonesty, and then I'm going to do something that literally you might involuntarily do the where your hands do the you blew my mind. I'm going to write out this equation, x squared plus 6x plus 21. I've moved the 21 over and got 21. You are not the magic number. You are not the chosen one. I'm going to move it over. Then I'm going to switch colors. Chris wants to steal my moment. I'm going to let him do it. Go ahead. Are we saying y is 0? No, not yet. Yes, I know what you're talking about. Yep. What number did I want? What's my magic number? 9. So I'm just going to add 9. You should be upset. You should be like, not okay. Not okay. What number do we say I could add? 0. I can only add 0. You just added 9. Ready? Reach down, do up your seatbelt for this. This is good stuff. I could only add 0, so I did add 0. I added 9, and then I subtracted 9. And then, to make this happen, whoa, what happened there? I'm just going to underline these first 3 and go, let's just look at those 3 for a second. If I factor that trinomial, that 9 does a great job of completing the square. Because what 2 numbers multiply to 9 and add to 6? 3 and 3. This thing factors as x plus 3 squared. I'm not going to show the extra step here because I'm going to try and stay focused on the big idea. I'll keep that underlined. I'll underline it both. That is x plus 3 squared. I now had my 9. I completed the squared. The penalty I had to pay for having a plus 9 was a minus 9. But the minus 9 is like, okay, well, you go ahead and you be in the brackets. I'll go over here with the c value, and I'll combine with that. And I get now that's some good algebra. And all I did was add 0. An important 0. I had to make a wise choice on the 0 I was going to add. There's lots of zeros out there. 10 and negative 10, 20 and negative 20, 50 and negative 50. I had to be wise about the 0 I added. Now let's stare at that for a second. Can you see what the vertex is? Negative 3, 12. Can we agree that this is much faster than setting y equals 0, finding the 2 x-intercepts, adding together and dividing by 2, and then subbing back in? To which you say, so why didn't you just show us this first? All understanding is lost here. You got to know what you're doing here. Yeah? Because there's no piece by piece nature of this. When you're learning quadratics, the method I showed you is the right one. Once you've learned quadratics, this is a nice shortcut. Austin, question?
Do we get to choose between the 2 methods on a test, or do you tell us what one to do?
Now that's a good question. Generally speaking, when this is over, you'll only use this method. In fact, it wouldn't surprise me if I showed the method I've been teaching you to the grade 11s or the grade 12s. They'd be like, oh yeah, I remember something about that. But they'll have moved on from there. This has happened before to you. If I asked you to add 6 up 8 times, you wouldn't draw an array like you did in grade 10 or grade 2 and go 6, 6, 6, and then count them all up in rows. You now know it's 6 times 8. Yes? At some point you understood well enough that 6 rows of 8 is 6 times 8. Yes? So this happens in math all the time where you learn another level and then abandon what you had before. Okay? Aww. Sad. Sad. We will do more of these. So if on a scale of 1 to 10, you're like understanding a 6, you're like, I'm sort of with you, but actually doing about a 3, you're like, I don't know if I can do this. Well, that's what the rest of the lesson's for. You have just completed the square. The process of adding and subtracting a constant to a given quadratic expression to form a perfect square trinomial. It is also the process that converts here, this gets the highlight. What does this thing do? It converts quadratic form into standard form. Standard form into vertex form. Here's the procedure. I hope you found out. I'm not addicted to these procedures things, but they're there if you want to look back at them. Half of b and square it, find that magic number. Add the number and subtract the number, then factor it and collect the terms. Seems all pretty straightforward, and it actually is, if a equals 1. And today a will equal 1. Do not be afraid. If you practice the a equals 1 version, the other version won't seem like that big of a deal. There's just an extra 2 steps in the whole thing. So, for each of the following, complete the square. And then once you're done that, see if you can do the stuff we already know how to do, but now quickly and easily. Ready? Here we go. Here's how I suggest to do it. When you first get given this, write, I'm going to do it in green, write y equals x squared plus 12x, and then leave a gap and put the 14 over there. Could you run into a question where that number, that c value, is the right number from now on? It's possible, but very, very unlikely. Most of the time, that 14 won't be the correct number. What is the correct number to complete the square? 36. That's going quickly for some people now. But if the number's crazy, again, I'm going to write it over here. Somewhere on the page, you got to go, okay, b divided by 2 squared is the 12 divided by 2 squared, which is 6 squared, which is 36. We okay? Magic number is 36. I need 36, so I add 36. Someone raises their hand and goes, you're not allowed to add 36. You can only add 0. That's the only thing you're allowed to add. That doesn't change this. So how do we fix what's just happened here? Then also subtract 36. And if you're having trouble with this at all, now underline the first 3 terms to go, there, I completed the square. What 2 numbers multiply to 36? Did I add 12? 6 and 6. I'll show the extra step this time, but you don't have to. You might be like, yep, got it. It's 6 and 6, so that's x plus 6 times another x plus 6. And then what happens over here, the negative 36 and the 14? Fortunately, those are like terms. They can just be added together. And my last step is to write it in vertex form. And again, most people, I think, jump from there to there. And that's okay, but I'm now back to teaching mode where I'm showing all the steps that happen. Yeah, I know, no. I just wrote negative 32 there. I got distracted. I got distracted. Thank you, good catch. I'd like to claim I did that on purpose, just to see if you were paying attention. But that is not what happened. Technically, that was single I. Now I'm ready for double I. Now, just remember what this is replaced. This is replaced, set it to 0, factor, find the 2 zeros, add them together and divide by 2, and sub that back in. That's what that 2 lines, I say 2 lines, because I think most people will start doing it in 2 lines after you practice it. That's what that 2 lines of algebra replaced. What did it lose? All understanding of what's going on. You've got to know what you're doing and know what this means.
Wait, so you did this on the test? You marked it as wrong?
No, but some of the questions on the test ask you to go through the procedure.
Okay.
Yeah? And I just showed it to you now. To break this thing out tomorrow, boy, you'd have to be confident. Yeah? I'm not against it, but maybe be careful. Yeah? Until you've practiced it a lot. Yeah? Can we do double I easily? Identify the coordinates of the vertex. I hope so. You need to be able to do that tomorrow, which is be able to just look at this and pick the vertex off of there. I hope that's very straightforward. Triple I, determine the equation of the axis of symmetry. This question does it all in reverse now. The old way, we got axis of symmetry right away. The new way, you got to know, okay, the axis of symmetry is x equals the x value of the vertex. Does it open up or down? Well, that's supposed to be easy for us too. Does this parabola open up or down? Up, because it's positive a value, so this is up. And state the optimal value. Y equals negative 22 when x equals negative 6. That's all questions that we could do before I showed you how to complete the square, but maybe in a different order than you're used to. Well, let's not wait around till tonight. Or no, not tonight probably. For most of you, tomorrow night after the test. To find out you don't know what you're doing. Give this one a try. If you're really not good at it yet, that's okay. I'll just show some steps over here. You can try it out, and you can peek at my steps to make sure it's going okay. On the video, I'll explain as I go quietly so that they can do their work. Getting the magic number here. Use that magic number, add and subtract it, which is allowed because you're adding and subtracting the same number So you're actually only adding 0. I know. How'd it go? Or do you need more time? More time for part I? No. Okay, so do part I, and then, as practice for tomorrow, try double I, try triple I, IV, and V, because those are some things that we got to be able to do tomorrow on the test. I'll give you a minute or so to do that, and then I'll ask for some people to share their answers. You want the Hulk, do you? Okay, you ready to answer you ready to answer the next question? Do you have it? Double I. Are you ready? Do you need more time, friends? No. Okay, good, he says. For the Hulk, what's the vertex?
Negative 5x. And then plus 22. Oh, you did it wrong. It is negative 20.
Yeah, negative 28. And then what's the x value of the vertex? Positive 5. Watch out for that tomorrow. It's easy to get that wrong, especially when you're rushing, right? You're on a test, you're moving along. Take a second to make sure you're reversing that. Equation of the axis symmetry? Lena? X equals 5, just the x value of the vertex, basically. IV, state whether it opens up or down. Up, because the A value is positive. And then what's the last thing? Y equals when x equals 5. That's the stating the optimal value thing there, okay? Questions there? Nuh-uh. More time there? Hopefully not. Hopefully you moved through it. Oh, the A value. If the A value is 1, the step pattern will be positive and this thing goes upwards. If the A value happened to be negative, which neither of these were, if it was like negative x squared, then the step pattern would be negative and this thing would be opening downwards. Okay, good. Graph the parabola. Okay. We got this now. Complete the square. Maybe you don't need it with this one. Can you do it in your head without writing it over there? I'm not saying don't write it over there. That's not what I'm saying. It's just with reasonable numbers, hopefully you can do b over 2 squared pretty quickly. What's 6 divided by 2? 3 squared. What's 3 squared? 9. So we go plus 9 minus 9. Factor that first set, that trinomial. What two numbers multiply to 9 but add to 6? Yeah, 3 both times. And then this negative 9 and positive 7 combine to make negative 2. Nice, huh? It's okay if you're angry a little bit at me. That's the right emotion to be like, why didn't you show us this first? It loses all understanding of what's going on. It doesn't show x-intercepts, it doesn't show x value of the vertex, subbing in, it loses everything, which I'm for. That's why I showed it to you. At some point, we got to grow past that. But there's a reason we do it in the order we do. What were the two things we need then? What do we want to graph? Vertex and the step pattern. So here the vertex and step pattern. I'm worried about this reversing of sign tomorrow. What do you get for the vertex? Negative 3, negative 2. And the A value is just 1 here, so the step pattern is just 1, 3, 5. So I will graph in red Vertex -3, -2. Over 1 up 1. From there, over 1 up 3. And from there, over 1 up 5. And tomorrow, friends, let's get this down pat where the parabola goes to the edge of the page with an arrow on the top indicating it goes on forever. You like? You happy? C is 7. And actually, that was a nice check here. The y-intercept was 7, and I had y-intercept 7. Yeah, it's a little, just a little tiny check there to go, yeah, does this all work out? Tim? For the next question? Decimals or fractions? Well, that depends. Where do you want to work long term? If you want to work at Apple, you'll use fractions. If you're okay with working at Samsung, then decimals are fine.
Why do you hate Samsung so much?
I don't know. That came up. Years ago, I had an Apple phone, and some of the people in class had Samsung phones. But that was the year, I don't know if you remember this, a bunch of the Samsung products had problems with a big pink line on the screen. Like it was a low failure rate, but it was famous that the Samsung ones would get this. So then, boy, us Apple people, we had a heyday making fun of everybody with these pink lines in their screen, and they had to get the. Yeah. So then I took it to say, well, that's because they round. That's because they use decimals at Samsung, and it was all nonsense, but it was fun, So. I challenge you to do these in fractions. The fractions, I'm sorry, they will keep coming back to haunt you again and again and again. So, the only difference here is 3 divided by 2 squared. And I know it looks bad, friends, but it's not that bad. 3/2 squared, you square the top, you square the bottom. You got 9/4. And I know that upsets you because it's fractions, but let's just go it one step at a time and see how bad it really is. Now we need somebody who sort of sees what's going on here. Because I kept saying something over and over again. I kept saying, what multiplies to 9/4 but adds to 3? But let's go back and really look at what happened in the brackets every time. And Chris was sort of on it at the start, and I should have made a bigger deal about it, but I sort of let it go. If it was 6x, it ended up being 3 in the brackets. -12 became -6. -10 became -5 in the brackets. Maybe there's a different way to think about this that's a little bit even faster than what we've been doing. -8 became -4. 6 became +3. Are you seeing the pattern? When it was 12 as the b, what was in the brackets became a 6. When it was -10 as the b, what was in the brackets was -5. What happens every time to the b value to get into the brackets? It's half. And actually, that relates to why it's half squared. If you want, what goes in the brackets is half, and then what comes outside the brackets is the half squared. Okay. So maybe this isn't as bad as it seems to factor this. What's half of 3? 1.5, yes, I know. 1 1/2, yes. I encourage you to use 3/2. I encourage you. I can't over-explain that right now. Right now you're like, why? That's more difficult. It's not going to be more difficult. That was these 3 terms. Now -9/4 plus 1. -9/4 plus 1/1. Ooh, I like that. Because then 1/1 can be made into 4/4. And I get this. X plus 3/2 squared minus 5/4. So Todd, this lesson was going really well till you and your fraction showed up. Listen, I am just the guide on this journey. I didn't create the orcs and the goblins. I'm just telling you how to deal with them. Huh? I'm Gandalf. I didn't cause the problem.
You know open sesame?
Fractions are a problem. I'm just telling you how to deal with them. Well, let's try another one that gets completely out of hand. Magic number. -7/2 divided by 2 and then square it. How do we multiply, or sorry, how do we divide fractions? I gave it away. Oh, yeah, maybe you already understand where it's going, right? Multiply by the reciprocal. So this is -7/2 times 1/2. And I get -7/4. And it is possible to go, oh, I totally get that. 7/2 divided by 2 is 7/4. Maybe that's not a fraction operation at all. That's just sense. And so here I get 49/16. Mr. Tom, my calculator does fractions. I just typed it in and I got the answer. Yeah. Yeah. It's true. It's true. What happens in grade 11 when it's b/a? The calculator can't help you anymore. That's where we're going with this, is being able to do fractions with algebra built in. And if you don't have your fraction operations down pat, you won't have any chance at all. So that's just my fair warning to you. This is the way. This is the way. I'm not doing it to torture you. I can do all sorts of other things just to torture you. What's that? Well, I could ask a lot more word problems in the test, couldn't I? I could. No, I'm well beyond being affected by the behavior of anybody who's under 30. Yes? It's all just comical to me. Now, please don't forget, the homework's not going to have 100 of the fraction ones. It's going to have a couple at the end. The test isn't going to have a zillion fraction ones. Have one on there just to go, okay, let's just see what you got. A lot of them are 3s and 4s and 8s and 5s and, you know, all the numbers that you know since kindergarten, yes? But now we need someone clever, and maybe somebody can give us some good news in all this. What's the number that goes in the bracket? -7/2, but half of that. It's right there. The number that gets squared is right there in your calculation over there. So remember when I said go off to the side and do b/2 squared, and then I sort of said, well, no, don't if it's a nice number. When it's a nasty number, go over and do this work, because a lot of everything you need is over there. This is -7/4. What about a common denominator between 16 and 4? It's not 4. 64 would work, but I don't know if it's the best choice. 16, yeah. So take this thing and change it to 44/16 by multiplying top and bottom by 4, and then I'm done. And you can be sad about the fraction situation. That is fine. Be sad and get it done. Just don't cry on your work. It smudges your pencil marks, okay? It's like eating a taco, right? It's off to the side a little bit, you know what I mean? Like just cry over here a little bit. Yeah? And those of you who engage with what I'm saying and knock down this fraction stuff, in chapter 2 of grade 11, you'll be like, oh, I'm sure glad I listened to Mr. Todd about that fraction stuff and just got to work and got it figured out. Because it's not, sorry, it's just common denominator. You were doing this in grade 7. You just got to scrape the rust off on your brain and go, how does this work again? Do you have questions? Can we not do this? Yes. Yes, you cannot do this. It's always a choice, isn't it? Everything's a choice in life, isn't it? Right. It's a great strategy. On the test, you could ignore all the fraction stuff, and you still get 80%. And then after that, you'll get like 60% in grade 11. No, I wouldn't. No, maybe, actually, seriously, maybe that is the difference between grade 10 and 11. Grade 10, we're like, okay, well, let's make sure we do one with a fraction. Let's do one word problem. Like and then grade 11's like, sorry, nice time's over. It's time to start really getting ready for university. That's why this is called grade 10 academic, and grade 11 is called grade 11 university prep. It's like, enough, let's go, yeah?